Today, I would like to talk about processing of metallic materials. I would emphasize on vacuum induction melting and thermomechanical treatment. These are two common processing techniques used by materials engineers in processing metallic material. But before I go further, I would like to show you a few wonders of engineering. The first one here is the tallest building in the world, named Burj Khalifa. It's about 828 meters. It has about 200 floors, and 39,000 tons of steels were used in the construction of that building. So I would also show you the longest, the longest suspension bridge in the world, which is Akashi Kaiko Bridge. There's a lot of steel used when constructing the bridge. Also, the Museum of the Future, which was constructed based on some algorithm, has a lot of steels used. So metallic materials are quite versatile in the development of structures and wonders of engineering. But let me ask this question. What makes it possible to build these structures? It's because we have materials that are available and we have processing methods available. We are able to process the materials. That's why we are able to build these structures. The next question is, what do we know about these materials? We know their properties. And how do we know the properties? Because we are able to test them. So, what is the role of materials engineers? The role of materials engineers is to actually understand the relationship between processing, structure, properties, and performance of materials. And to break that down, it means that our role as metallurgical engineers is to develop new process or modify existing processes such that new microstructures emerge. And when we have that, these microstructures can then influence the properties of the material. And once we have properties of materials, then these properties determine the performance of the materials in service. So let me give you a few examples of the processing techniques that we used in metallurgy or materials engineering. We have casting, which is something that we'll talk about today extensively in the laboratory. We also have powder metallurgy, which we wouldn't talk about. We also have heat treatment and, of course, thermomechanical processing. These are all examples of processing routes that materials engineers adopt in developing materials. But today, our emphasis will be on casting, which helps us to develop new alloys, and of course, thermomechanical processing. So now to casting, you can see a few components made from casting on an industrial scale. But on a laboratory scale, what you could do is to have a sand mold. You put a pattern in that sand mold and you ram with the molding sands. And after that, you can then dress the mold, lift out the pattern, and then you pour your liquid metal after melting. You won't be able to melt without a furnace. And that's why today I would show you how vacuum induction furnace works. Then when you pour the hot metal into the mold, you can remove your component. This is on a laboratory scale. But in an automated section, you could have a vacuum induction furnace as shown, and I will be demonstrating how that works in just a few minutes. Now let's go to heat treatment. You can see a component that has been produced that is being heated up to certain temperatures in a furnace, as you can see below. Then that particular component is then immersed in water to quench the component. That helps to improve the properties of the material. Then on a laboratory scale, we have small furnace called morpho furnace that could help do that. But we won't be showing that in the lab today. We have series of thermomechanical processing techniques. One of them is forging on an industrial scale, and a schematic diagram of rolling, which is also carried out on an industrial scale. Rolling is used to produce components like high beams, sheets, and many more. But today, I would show you how we carry out these thermomechanical processes in the laboratories using a machine called Global Thermomechanical Simulator. And results from the Global can be used as it can be used for simulations on computers. I'll talk more about that when we get into the lab. So now it is time for us to visit the laboratories.